Victor, where can I access the previous lessons recording?
Do you have access to Moodle?
Yes. Where do I go in Moodle?
All the presentations are Moodle.
Oh, okay.
I will forward you the recording as well.
Thank you very much.
Finish these sessions, I will send you a link on this. No problem.
All right.
Okay,
so let's begin.
today, yeah. So in today's session, we're going to look at understanding the computer system and component. So from our indicative contents, today we're going to learn about hardware component. So we will look into everything such as arithmetic and logical units. So we will cover what motherboard, CPU, and all the physical components that assembled will make our computer. Then we'll look into software components, and we'll look into the type of software and their use. And then we will look into open source versus closed source, and we will now understand what are the difference and the contrasting between both of them. So I'm assuming simple concept because it's at the fundamental of any ICT unit. So what do we mean by hardware? So by hardware, we're just going to define all those physical components that once they're assembled all together will now give us a completely functioning PC. So there are various components which put together they allow us to do it. So as we all know, a PC cannot run without a graphic card. So you cannot
Yes.
have a image.
Actually, a CPU.
So we
Not
cannot
the
have a
graphic
modem.
card.
Yes, exactly. So graphic card gives us more resolution. It gives us more higher quality of image. So
Yes.
we cannot have a PC without a CPU, as you said, or without a motherboard. Then also, our system cannot work without the software. So what do we mean by software? As you can see, a software is simply a set of instruction, data or program used to operate a computer and execute specific tasks. So I don't know if you're familiar with any type of programming language, but
yeah, I am, like Python, C++, C programming, HTML. Technically, it's not a programming language exactly. It's
you have knowledge with programming language, right?
yeah.
Hello?
Well, can you hear me? It cuts
Yes.
again.
Yes.
Well, I don't like. I've only done HTML and CSS in depth. I haven't done Java or C++ or Python yet.
Okay, no problem. We will get into that during our coding and web unit. So we will learn programming for that unit. So this unit, I'm just giving you an introduction to them. So as we all know, in order for us to have a fully responsive, to have a software, this has to be hard coded. So this has to be done with the programming language. So most of the software, depending on if it's a web application or a desktop application, this will be now written with a specific programming language. So depending on the nature, so if it's a software on the web, we might be using Python or JavaScript, while for a desktop application, we might look into something like C++ or even Java. And yeah, all this together allows us to have a fully functioning computer. So I do have a really nice video, which I wanted to share with you. You can watch.
If you work with computers, you've likely heard terms like RAM, hard drive, and processor mentioned by tech support or others who are more interested in what goes on inside of a computer's case. If you've always wondered what the various components of your computer are for, but have never really had the time to look into it, then this video is just for you. While each one of these components is complex enough to spend a lifetime learning about, I'm going to give a very broad and general overview. A typical desktop computer comes down to these 7 essential parts: case, power supply, motherboard, CPU, RAM, hard drive, and graphics cards. These are the fundamental parts of any desktop computer. It may seem daunting at first, so let's separate these into 2 categories: simple ones and the more complex ones. For starters, let's look at the case. The case is nothing more than a big hunk of plastic that houses everything else. Some of them have more or less physical space, some of them have different parts where you can put screws in or this or that, but at the end of the day, all the case really does is provide a nice enclosed system for everything else. Next up, we have the power supply. This part of your computer, almost always located on the bottom, is the part that plugs into the wall and provides all of the other parts with the electricity needed to do their thing. You can think of it as an extremely advanced AC adapter. The last of the simple parts to mention is the motherboard. The motherboard is a wide and flat circuit board that all of the other components plug into. It's the part that lets all of these components send electrical currents composing data between each other. While not particularly expensive, the motherboard is arguably the most into. It's the part that lets all of these components send electrical currents composing data between each other. While not particularly expensive, the motherboard is arguably the most important component because without it, you'd have nowhere to put anything else. So that's it for the simple components. Now let's move on to the more complex parts, the ones that deal with data. The 4 main components to keep in mind here are CPU, RAM, hard drive, and graphics card. Now, first things first, I'm going to establish some terminology. Keep in mind that CPU is also known as the Central Processing Unit, or processor. These terms all refer to the same thing. They're completely interchangeable. RAM stands for Random Access Memory and is often referred to as just memory. A hard drive is often referred to as a disk drive or storage. And a graphics card is also known as a GPU or graphics processing unit. For this explanation, I'll be using the terms CPU, RAM, hard drive, and graphics card. So let's start with the CPU. The CPU is where your computer does things. It isn't really capable of storing very much data at all, but it's very good at doing things with data. Quickly reading it, arranging it, doing the type of quick and massive calculations needed to run your programs. This is where most of your programs are essentially run from. It's often referred to as the brain of the computer. I personally don't like this description because really your entire computer is just a brain. It's just the center part of your computer's brain. Basically everything that happens in your computer goes through your CPU at some point. Now let's talk about RAM and hard drive at the same time because they have a very unique relationship, which is probably why people often confuse the two. Your hard drive is where all of your data is stored. When your computer tells you you're running low on space, it's because your hard drive is almost full. All of the data that makes up your videos, pictures, documents, project files, or the 3D worlds and models that make up a game are all stored here. While hard drives can store lots of data, they're relatively bad at accessing that data quickly. Everything is accessed through a tiny little wire here, and because most hard drives are made up of spinning disks, your hard drive isn't going to be able to constantly give your CPU the information it needs to run certain programs. That's where RAM comes in. RAM is another form of storage. It stores the exact same kind of data as your hard drive, but RAM sacrifices storage space for nearly instant accessibility. Unlike your hard drive, which sends all of its data through a tiny little thin wire, Your RAM is arranged in these long, thin sticks that insert into your motherboard. Think about a storage unit. If you have a massive warehouse with only a thin doorway, it's going to be difficult to get in, find what you need, and get out if it's kind of spread all over the place. You'll have to go through a tiny door. But if you have a long, wide storage shed that's got a big, massive garage composing an entire side of it, you won't be able to store as much, but things are significantly easier to get to. Typically, if your computer has 1,000 gigabytes of storage space in your hard drive, it's likely got about 16 gigabytes worth of RAM. Here's where you put the stuff you own but you aren't currently using, and this smaller one is where you put the stuff that you are using and need to be able to get in and out of quickly. When you run a program or a project file, your CPU identifies what parts of data are needed for that program to run. It pulls them from your hard drive, and then it stores them in your RAM sticks for quick accessibility. This is why when you start a new level of a game, for instance, it has to load. Anytime you see loading, it's loading the data that composes that level from your bulky hard drive into your RAM. From a user's perspective, just follow this rule of thumb. RAM allows you to run intensive programs, while disk space allows you to have more of these programs installed. It also allows you to have more of the data they're referencing, whether it be pictures, videos, or mods. And finally, we get to the graphics card. With all of the calculations going on in your computer to turn a bunch of numbers that basically come down to ones and zeros into a constantly updated three-dimensional world, the final and most important and arguably most difficult step is to display that on your monitor. It's possible for your motherboard to do this alone, but it's not going to look good, and it's certainly not going to be able to do much. Your graphics card is essentially an entire computer in and of itself, dedicated to the sole task of figuring out what pixels need to light up on your screen, in what color, and at what time. If you were playing a game that had a very busy and high texture world with lots of models and different angles and colors, your CPU is the thing that creates that world. It knows where the stuff is, and it does so with data that's been stored in your RAM, which was loaded out of your hard drive, but it's your graphics card that figures out what it's supposed to look like based on where you're standing in the world. Without getting too off topic here, if you're somebody who likes math, I highly recommend you look up fast inverse square root, which is directly related to how three-dimensional worlds calculate perspectives. So that pretty much sums it up. There are other components worth mentioning, such as cooling systems or internal wireless cards, but really those are extras. So to summarize what I talked about so far, the case stores everything in a physical box. The power supply gives electricity to what needs it. The motherboard is the body that everything plugs into. The CPU does everything. RAM stores data that is needed for quick access. Hard drives store everything that you have installed and the data that goes along with those programs. While the graphics card figures out how it's all supposed to look on your monitor. Well, thank you very much for watching. I hope I helped, and if you have any questions, feel free to leave a comment, and I'll do my best to answer them. Liking and subscribing is always a big help, and I plan to put out many more videos explaining technical concepts such as this one.
Okay, so I think you enjoyed the video, and it gave a
Yes.
very good insight of how we assemble a computer. But as you know, now it's 2023, and we do have built-in computers where you don't need to assemble. Maybe if you're familiar to Mac, the Mac has everything built in, has camera, speaker, motherboard, CPU, everything built in the monitor. So everything is behind the monitor, so you don't need to assemble like how we used to do back in the days. So, but if you find ICT and hardware components interesting, something that you like, and maybe you might find interesting to pursue a career as a hardware technician, would be really nice for you to maybe try to build a PC from scratch, so you can order all the components from Amazon. You can get everything from Amazon. You can buy CPU, you can buy a RAM, you can buy anything like the monitor, and you can just assemble all the components. Maybe you can go through YouTube. So there are good tutorials where they will show you how to connect all the physical components. So maybe maybe you don't want to waste money buying one in a shop where these people they're trying to sell and they don't sell good product, in my opinion, because I think they will sell they will just advertise, maybe say, oh, this has a really good resolution, is the new one, but at the end of the day, there's a 4 GB RAM, maybe it's a really old processor, but because it looks good and new, people don't have much of ICT skills, they will now end up buying it for a really high amount of price. So it's always best to do the appropriate research when it comes to buying a computer, a desktop PC. So
Yes.
so the video explained to us different components: motherboard, CPU, graphic card, RAM, and storage. So moving on, the video explained in details what they are. So on the motherboard, which allows us to have the electrical components, connectors. So we are able to connect input devices and output devices to our motherboard, and our CPU sits on the middle of our motherboard. So when you open the motherboard, there will be a square space where our CPU will now be placed in. So when it comes to CPU, there are different type of brands. So we know Intel, which is one of the most famous brand, has
Yes. AMD as well.
Yeah, AMD with Ryzen. So they have different type of version, starting from maybe Ryzen 3 to Ryzen 9, while Intel has from Intel 3 to 9 and other advanced models, very advanced, depending on the nature or the reason why you're buying your PC. So this will come down also to know if it's for depending if you need it for gaming, for work, you just need it because you're a student or maybe a programmer. So depending on the reason, you now choose the appropriate CPU. And how the video explained before, in the CPU, here's where it is written the line of code. So there is something you need to understand about programming languages. So I think out there is 20 or even more, and there are high-level programming language and low-level programming language. So the high-level ones would be classified as Python, JavaScript, and all these new languages where they don't work with a compiler, so they work with an interpreter. So what they do is basically the programming language will now try to interpret it and try to understand what are your input. So languages like Python do not require you to declare every type of variable, every type of data type. So the way they work is way more flexible because you try to understand what you're trying to declare. While low-level languages like Java or C++, which are a bit more old, they require to have a compiler. So what happens is that all these programming languages are written in English language, and once this language is being converted, our compiler will now convert the English language into binary numbers. So we all know that computers understand binary numbers, which is a sequence of bits of 1 and 0. And once this message is done and executed, we will reconvert it into English language and will now have an input coming from our CPU.
All right.
Okay, so we have graphic processing unit. which is our graphic card, basically. And as the video said, if you want to have a really high resolution of the image when you're playing a game or something, you now be required to have a really nice graphic card. So with this PC, the old one where you have the case, they always have an extension. So this extension will allow you to, so you can purchase a graphic card from Amazon, for example, a powerful one, and you can extend it to your PC to increase your resolution. So what happens is that you now have to disable your old graphic card driver in order for you to install this new graphic card, which will have a higher resolution of image. Or maybe you can directly buy a PC with a really high graphic card.
Yes.
Also we have random access memories, which we all know is the memory that allows the PC to access data as fast as possible. And it is random due to the fact that once you switch off your PC, all this data will disappear. So it's volatile. And yes, so it's a volatile memory. While the difference with ROM, ROM, it is a memory that stays there. So every data, like your pictures, photos, videos, will now be stored into it. So there are two types of ROM. We have HDD, hard disk driver, or we have SSD, which is a solid state driver. SSD are more recent, so SSD you might find them on laptops. So in the new generation of laptops, they will contain this SSD, and because everything in this new laptop are built in. So while with a hard disk driver, it's a bit more external and it is easier to replace. While a SSD, it is a bit more trickier to extract. And also HDD are cheaper, and even you can buy an external hard drive, which you can just simply plug in into your PC and use it as an external memory, and this HDD. So now we're going to look into the layers when it comes to delivering system applications. So at the rock bottom, we have hardware, which is the fundamental. Then we have operating system. As we mentioned, there are three major operating systems, which are Mac, Macintosh, Windows, and Linux. So
yes,
I'm not sure if you're familiar with Linux operating system.
I've never had a MacBook, so I've never used Linux.
No, Linux is a operating system in itself.
Is it Mac?
No,
Linux. It's never mind. No, I got confused. Sorry.
no. So Linux, it is a really powerful operating system. So even Windows machine, they are based on some Linux fundamentals. So there are three different type of operating system. So a Linux operating system, you can run it through a virtual machine. So I don't know if you're familiar to virtual machines. Virtual machine, you can just install this machine on a desktop, and once you install this machine, you can now download Linux operating system, and you can now browse and understand. And wait, let me just show you the video to be more clear. So what I'm trying to explain is that there are various way for you to run Linux operating system. So when it comes to cybersecurity, ethical hacking, this governance and security level, Linux, it is the best of all time operating system. So let me just show you a brief video which will Linux.
Are you a professional looking to immigrate legally to the United States? Today we're going to talk about one of the best options.
Hi, I'm Denshi, and in today's video, I'm going to be talking about the Linux kernel. I'll be mainly talking about what kernels are, how they work, and what makes the Linux kernel any special. But anyway, let's begin this video with a rhetorical question. Have you ever used an Android smartphone, or used an ATHE machine, accessed the modern internet, or used a GNU Linux operating system like Ubuntu or Fedora? Now, you've probably answered yes to at least one, if not all of those questions. Well, that means that you've already interacted at some point with the Linux kernel. But what does that even mean? What is a kernel? Well, to understand what a kernel is, you must first understand that a computer needs both software and hardware to do anything. So to make it easier for a piece of software, like for example a web browser, to interact with the physical components of the computer, it makes sense to have a layer of software that acts as an abstraction between the hardware and the software that needs to use it. So, for example, if software on your computer needs to do something with the hardware, like open the CD tray, then instead of giving the motherboard the direct signal to open the CD tray, which might be a different signal depending on what motherboard you bought and what CD tray you use, the software can instead just tell the kernel to do that. In this sense, the kernel acts as an abstraction layer between the hardware and the software. Okay, so that's all well and good, but how does a kernel actually work? Well, most kernels work by responding to system calls. These are called by different parts of the operating system to get the actual physical hardware to do things. An example of this is your C library. If you run software that was written in C on your computer, then it's up to your C library to give the appropriate kernel system calls to make the computer actually run it. Now, that is a gross oversimplification of the process, and if you want to learn more, I have a page linked in the description that explains the process in far more detail. But moving on to the topic at hand, what is the Linux kernel? Linux is a kernel created in 1991 by Linus Torvalds. It's been in constant development since then, and is now at version 5.11.12, although that's probably changed since the making of this video. It's used in desktops, laptops, smartphones, servers, and many more devices. Okay, but what makes Linux any special? What makes it different from the other kernels out there? Well, first of all, it's open source, so anyone can see the code to Linux, download the code to Linux, and compile the code to Linux. Second of all, it's free software, so anyone can share the code to Linux and the finished kernel, and they can do anything they want with it. And third of all, it's very fast. Linux is consistently more efficient and faster than most other kernels in mainstream operating systems. The reason it is so fast is because it's free and open source. You see, Linux has become the de facto standard for any specialized OS that requires efficiency. And this is all because anyone can download the source code to Linux and compile it the way they want it. This means that any unnecessary features can be removed, which makes the system more efficient. So, for example, over here in the corner there's a smart toaster, and that's quite obviously running Linux. The reason Linux is used rather than Windows or Mac OS is because the Linux kernel is open source and can be modified to be perfect for this toaster. And that's truly the greatest thing about Linux. It can run on everything from an integrated system to a supercomputer because it's so customizable. Alright, so now we're getting a little bit more practical, but how does Linux actually work? Well, just like any other kernel, Linux accepts system calls to perform functions. And like some other kernels, Linux utilizes kernel modules to handle which parts of the kernel to activate or deactivate. These can either be disabled, enabled, or rendered toggleable at compile time. An example of a Linux kernel module is PC Speaker. This can be enabled or disabled with the mod mod probe command. If disabled, your PC speaker will no longer make annoying bleeping noises. So I have a practical example for this kernel module. I have a software over here called FileZilla, and every time you try to press backspace in any FileZilla entry, like the host, as you can hear, it makes a PC speaker noise. Now that's built into my actual computer. It's emulated, but if you were on older computers, there would actually be a physical speaker that would make that bleep. Not part of your regular speakers, but a dedicated speaker for that. And because Linux is so customizable and so controllable, we can just completely turn that off. So if we open up our terminal and run sudo mod probe -r PC speaker, and then we go over here and try to do it again, as you can see, no more bleep. So with that mod probe command, we've essentially disabled an entire part of the kernel, which is support for PC speaker. Now, when we reboot our system, it will come back, and we can re-enable the PC speaker support with the mod probe command. But that's just to prove how controllable Linux is. Now, it's not all sunshine and rainbows. There are some negatives to Linux. For example, the fact that Linux is very monolithic, even more than Windows NT and macOS's Darwin kernel. What that means is there is a lot more built into Linux than there is on other kernels. This includes GPU drivers and drivers for peripherals like pen tablets. Essentially what this means is if you were to plug in something like a pen tablet or use a different graphics card on Linux, then you wouldn't really need to install any drivers. It would just work as long as it was supported by the kernel. However, it also means that you don't really get the option to change or remove any features from the kernel even if you're not using them unless you're willing to compile the kernel yourself. And this is why compiling the kernel is so popular. It's a very large project with support for lots of hardware that you're probably not using. And that's why it's convenient to go through there and delete things that you don't need. Another negative of Linux is that it's developed very rapidly, which means that if you choose to always use the latest kernel, you might encounter stability or security issues. Now this is essentially a non-issue because most people don't use bleeding edge kernels. However, some features are deprecated from Linux from time to time. Well, that's pretty much all I have to say. If you enjoyed this video on the Linux kernel, you might enjoy my upcoming kernel compilation guide. That'll all be coming soon, but for now, I hope you enjoyed this video, and goodbye.
I fail to see how one of the negatives of Linux is that if you plug in anything, it doesn't require drivers or anything. It'll just work perfectly by itself. How's that a negative?
No, because he said because they have constantly updates on Linux.
Oh,
So because it's very fast, on the way they keep on updating it. That's why the moment you learn something, there's already something new running on Linux operating system.
right.
Yeah. So I'll say Linux is a really interesting operating system because with Linux terminal, you're able to run a lot of pen testing or cybersecurity attacks. So Linux terminal is very, very good. I'll suggest you to look into some basic tutorials or even look into some certifications. So there are certifications like CompTIA Security Plus, CompTIA Pen Testing Plus, which gives
Yes, I'm familiar.
yeah. So they give you a proper certification, and you will be working on these virtual machines. So with these virtual machines, you have maybe 2 or 3 of them which are running as on the Windows machine, and you might be required to work with them, access them as an administrator. While with your fourth machine, your fourth visualization machine, you'll be running Linux or Kali Linux, which allows you to, with the terminal, to now gain access to the other 3 PCs. So yeah, I would suggest you CompTIA Plus certification. No, I mean, sorry, Security Plus open testing. Carry on.
Yes.
Application. So we do know what application programs basically. So these are just the applications that run on our desktop. Maybe if you're accessing this tutorial from your PC, you might have to download Zoom on your desktop. So by you downloading Zoom on your desktop, you're basically running a application program built from Zoom company, which they have the web version and they have also the application version. So there are, I don't know, millions of application software nowadays for any type
Yes.
of purpose or business. So we have device driver. So what do we mean by drivers? Every component that we install in our PC will now have to run a driver. So we are able to hear the sound, we're able to hear each other through our sound driver, or even our graphic card has its own driver which has to be installed in the PC for it to work. So every sort of input or output device will now have its own related driver. Operating system, so we introduced them, we spoke about Linux. I'm pretty sure you're familiar to Windows, and the Mac
Yes.
operating system is really good as well. So depending on depending on the nature of your job or whatever you doing, you might be required to buy a Mac operating system. So we have root user processor, which are programs that can run only by user with a root authority. So what do I mean by root authority? These are applications that when it comes to for the installation, maybe you might be familiar to Microsoft SQL Server. So this type of application, they might require you to do the installation through the root authority. So you have to do all the configuration. This has to be done through administrator systems. Okay, now so we're going to look into open source and closed source. What do you know about open source?
Open source is like GitHub projects where you can share the code and people can add or modify or do a lot of things, then re-upload it and share it with a whole bunch of other people. And it's also free to access unless it's closed. It's only a specific individual and it's private and nobody can see it and only one person can do it.
Oh, very good. Okay, I can see you have a good understanding. So open source are pretty much for developers. So for instance, you download Microsoft SQL Server, you now download the open source version, which is for developers, which will allow you to work on projects, exactly as you said, and this project can now be reused. While a closed source could be maybe an enterprise version. So maybe a company like Zoom, when it comes to do their own application, it might be running a closed source in order for security or, the rivals or competitive data. So closed source are pretty much, I would say, for enterprises or big businesses, while open source is more for like, developers. So you really got this right. So yeah, we have explained. Yeah. So is there any question for today's session?
No, that's it.
Okay, that's great. And then we see you tomorrow. So so we just have 3 learning outcomes for this unit. So what I'll do tomorrow, I'll do the 3rd learning outcome, then we will look into the assignment discussion as well. Is that okay?
Okay. Yes, no problem.
Okay then. And if there is no other question, I'll end this session now. Thank you very much for joining and have a good day.
You too.
Bye.
Bye.